Hello and welcome back aboard Bridget. This is the final video in my series on the electrical install, and this one will cover the navigation system. The nav system I've built is based on NMEA 0183, which is the old NMEA system. I've got some very good reasons for that, but it does get quite technical, so I'm not going to go into that on this video. If you want me to do a video on why I think NMEA 0183 is better than NK2, I can do that. Leave a comment in the leave a comment below and I'll do a video on that. I've also got an article coming out in Practical Sailor which goes through the technical details, what the difference is between the two systems. But I don't want to get too bogged down in the technical stuff on this video. I like the old NMEA system better than NK2. I think it has better redundancy, and for a budget boat, particularly the smaller boats, it has some big advantages. If you're looking at a 50-foot modern production cruiser, yeah, there's good reasons for going to NK2. That's what it was designed for. But I don't think it's the best solution if you're on a limited budget and on a smaller boat. I made the claim that the navigation system can be built for $3,000. That's the basic core system. If you compare that to an NK2 system, doing the same thing on NK2 could easily cost you $15,000, probably more. The reason for that is computers are a lot cheaper than chart plotters. Yeah, a computer is not waterproof. You have to put it downstairs. Okay, so these are my instruments at the moment. I have wind, log and depth. Those are on 3 separate instruments. This is one of the big differences between this system and an NK2 system. So here each instrument connects directly to its own sensor. So the log connects to an electronic log. The depth sounder connects to a sonar scanner. The wind instrument connects to the masthead unit. Providing their instrument is working, they will always give you a readout. They're not dependent on the network. So if you have a problem with the network, or you just want to turn it off to save power, it means you can turn everything else off. You could set this up if you really wanted to, so that you were only showing log or log and wind. Why would you need a depth sounder if you're 500 miles offshore in 5 kilometers of water? Why run instruments that you don't need just because you've got them? That definitely applies to standard chart plotters. A lot of people don't realize quite how much power they draw. If you have to have your chart plotter on in order to just run basic instruments like wind and log, then you're using a great deal of power that you don't need to. On a big boat that might be not be a problem. On a small boat it often is. Okay, so these instruments, they feed the computer system. So each of these has its own takeoff. This is on the NMEA 0183 network. So it's a plain cable, 3 wires. You can use any cable you like as long as it's shielded. They usually come with some cable, but you can use a nice hefty cable that's not fragile. If something goes wrong with it, it's a standard piece of wire. you can carry some spare and repair it at sea. Try doing that with an NK2 backbone where water's got into one of the junctions and blown the thing. Okay, this is the next part of the computerized system. So this thing called an ActiSense Pro NDC 1E, this is effectively a combiner. What it does is it takes the input from things like GPS or the wind instrument and combines those to give an output via an Ethernet cable that can be fed into the computer. Below you can see a 4-point Ethernet switch. What that does is enable me to plug other things in. So I can directly plug in things like solid state radar and anything else that comes with an Ethernet connection. And they will automatically feed into the computer and be available on the rest of the system. The other thing that the combiner does is it outputs a signal as well. So, for example, the wind instrument feeds a signal in. It's called a talker. Other things called listeners can connect that and read that information. So it enables you to do things like combine speed and wind data together to give you apparent wind. Means that on my electronic barometer I can output apparent wind or true wind, and I can do the same thing on the computer screen. I can also plug things like an AIS device into here, and that will then give me an AIS chart overlay. Okay, so looking at the computer side of things, we all use computers. We all use electronic navigation these days, for the simple reason that you can't afford to buy every chart going. They've just got too expensive and hard to get hold of. So this is my computer setup. This is a mini PC. It's about 4 times as powerful as any chart plotter you can buy. It's also got a massive memory. As well as running the navigation system, it works as a normal computer. So I've stored things like all of my manuals on there. I can use it for writing emails or sending emails. I can use it as a conventional computer when I'm not using it as a navigation computer. The program you can see running here is OpenCPN. A lot of this is just because it's cost effective. Notice the size of this screen. I'll measure it for you. So, that's a 15-inch screen. How much is a 15-inch chart plotter? We're looking thousands. Probably a couple of thousand. That was $100. I bought it a little while ago. I think they've gone up a little bit, but between $100 and $150, and you can get a perfectly good screen. It runs on 12 volts, so you don't have to worry about voltage conversion, and you don't have to have the inverter on to run it. The same with the PC. These mini PCs work on 12 volts. That's a huge plus compared to a laptop which runs on 20 volts. Control. Keyboard. Bluetooth keyboard. I've got a full keyboard. When it comes to things like putting in a waypoint, so much easier to type it in on a traditional keyboard. This one has actually got a waterproof cover over it that protects it from splashes and keeps the muck and the dust off. There's no vents or anything on the back, so it's not going to pick up water from the chart table. I've got the same thing with my mouse. Standard optical mouse means I can work everything. Most of the OpenCPN program works on mouse clicks. So yeah, that's great. This also means that I could, if I wanted to, take these into the so starting off at the chart table, we've got these two instruments here. These are not absolutely essential, but I find them highly desirable. It's a Navtex readout. Yes, you can get Navtex on a computer. The beauty of having a Navtex reader is this takes practically no power. You can leave it on permanently and it records its signal. You can flick back through previous ones, will take you back through the daily forecast for the last few days. It also gives you all sorts of navigation warnings. You can choose what you want, everything from where is the limit of ice at the moment, are there any icebergs floating around, is there a submarine exercise going on, is there a cable laying ship, is there a buoy out of place. All of those things will come up and record on Navtex, and it's dead easy to use. The other one is this thing called the Meteor Man. You can see at the moment it's giving a clear recording of the atmospheric pressure and temperature. It logs that and you can display it on a graph for several days. So it will show you the daily pattern. So let's go to history. You can see that's giving me a graphical pattern of what the pressure's been doing. You can see it was quite low for a while, then we had a high pressure over the weekend, and then it's dropped back down again. It's a very easy way to spot bad weather coming. If the pressure starts dropping radically, you'll immediately know. And again, having a recording over time is quite useful. This is showing 40 hours at the moment. The other thing this will do is you can link it to the weather instrument that's on your masthead. It will keep a record of wind speed and direction. You might find that quite interesting. You can start to analyse your boat's performance on different tacks, things like that from it, if you're into that sort of stuff. I must admit I'm not. But it's really useful in that it acts as a repeater for the weather instrument. So if I'm down here, I can see wind speed and direction. Wind speed, particularly, if I'm sat down here, I want to see if the wind's piping up, and that's quite a useful way of doing it. So as I say, those are two optional extras that you don't have to go for, but they are quite useful. Okay, so that runs through the rest of my electronics install and my navigation system. It's quite difficult to go into sufficient detail on a video. It's not the ideal format for it. So I'm going to plug some of my other work. If you're relatively new to sailboat restoration, if you're looking at doing your first project, my book, Budget Sailboat Restorations, is available on Amazon. That covers everything from how to choose the right boat for you, how to approach a restoration, how to work out a budget, how to stay on that budget, how to decide whether something is a feasible restoration project for your level of skill and your finances, or whether it's something to run away from. This boat I bought super cheap, but it needed everything doing to it. That's fine. I could do everything. That way I get a really nice boat that I really like for a relatively low price. But it's also taken me 2.5 years of pretty hard work. Not everybody wants to be able to do that. But you might be great at electronics but lousy at woodwork. So yeah, that's one sort of boat. So that's what I go through in the book. how to match your skill set, your experience to a boat which is right for the sort of sailing you're going to do. If you're going to the Caribbean, you want a different boat to if you're exploring the Northwest Passage or sailing across an ocean. And I go through all of that.